Right, good afternoon, good evening, good morning, dobre utro, dobre wieczór, dobry dzień. Welcome to Tutorials with Aubrey, where you get exclusive tutorial lessons. If you want to be receiving more tutorial videos, you can subscribe to the YouTube channel from which the link of this video will be put. So basically, we are going to look at we're going to start with complex analysis. Okay, and actually this is my first video in 2022. I'm wishing you a happy new year. So now to the incoming fourth years. In complex analysis, you will run into these two very important identities, okay, which is cos z is equals to e to the I z plus e to the negative I z over 2. So this is the first identity that you run into. The second identity that you might run into is sine z is equal to e to the I z minus e to the negative I z all over 2. So now these identities are very important because they will help you simplify trigonometric complex analysis functions. Okay, so sine z is equals to e to the iz plus negative, and so on and so forth. Right? So now what you need to know as well, apart from the application part of these identities, is their proof. So that is what I'm basically going to cover in this video. So we're going to prove the first one, which is we're going to show that cos z is equals to e to the I z plus e to the negative I z over 2. Now these two identities have a very simple proof because these are proven using Euler's formula, which is e to the I theta is equals to cos theta plus I sine theta, which is a formula you've been looking at since you are in first year, because when we introduce r both sides, this becomes what you know as a complex form of z, of which when we divide throughout by r, it becomes Euler's formula. So now, looking at Euler's formula, say where there is theta here, where there is theta, when you change theta and you put negative, or let me say negative z or positive z, or since we're looking for z, when we put z where there is theta, we're going to have e to the I z. Even this part will change to cos z plus I sine z. And as you can see already, the z part we are looking, the cos z part we are looking for is there. So now what is left is for us to look for a way to get rid of this part. And how we can get rid of this part is we can make use of this identity. We know that cos negative theta is equals to cos theta, and sine negative theta is equals to negative sine theta. So if we think in future, if we had a negative here, okay, if we had a negative here, then if we were to add up this with a similar of this, then it will cancel out. Or let me just show what I'm trying to talk about here. Okay, let me just show what I'm trying to talk about here. So now let's say we introduce now where there is theta here now, we introduce a negative z, then this will become e to the negative I z is equals to cos negative z plus I sine negative z. Okay, but we know that cos negative z is equals to cos z, and sine negative z is equals to negative sine of z, that negative sine of z. It means that this part, we can, this cos, we know that cos negative z is equals to cos zi. Here on this part, we know that cos negative z is equals to cos z. So it means that this part is the same thing as cos negative z without the negative there. And sine negative z here, okay, the negative can come outside like that. Okay, the negative can come outside, and we're going to have something like that. Are we following? So we've used these identities that are here to just change. Hope you followed that. So if you didn't get any part, you comment in the description or in the comment box below. So now from here we're going to add, we're going to add because this part and this part, it means when we add, they can simplify and cancel out. Okay, so now when we add this part, it will be e to the I. When we add this to be e to the I z plus e to the negative I z is equals to this plus this, will be 2 cos z, and this will cancel out. And what will remain with, we make cos 2z the subject of the formula by multiplying throughout by half. We're going to get cos z is equal to e to the I z plus e to the negative I z all over 2. Hence the first proof. Okay, so this is the first proof. We go on to the second proof.